Welcome back, everybody. And today we are going to discuss why AI changes everything and why every infrastructure engineer must understand AI. For decades, infrastructure engineers built systems which was primarily for human-driven application. Web servers handled website requests, databases stores transactions, and enterprise network connected offices, users, and the cloud services. Most workload were predictable, lightweight, and designed around CPUs. But the rise of artificial intelligence has fundamentally changed how modern computing infrastructure is designed, operated, and scaled. AI system behaves very differently from the traditional applications. Instead of serving a few databases query or loading a web page, AI workload process enormous volume of data, perform billion of even trillion of mathematical operations, and require thousands of processors to work together. A single AI training job can consume more network bandwidth, storage throughput, and electrical power than an entire traditional data center workload from a decade ago. This shift is transforming the role of infrastructure itself. For infrastructure engineer, AI is no longer a specialized field reserved for data scientists or researchers. Modern AI systems depend heavily on the networking, storage, distributed computing, virtualization, orchestrations, observability, and hardware acceleration. In many cases, the success or the failure of AI deployment depends less on model itself and more on the quality of the underlying infrastructure. A poorly optimized network can slow distributed GPU training, insufficient storage, throughput can strip GPU of data. Improper scheduling can leave expensive accelerators underutilized. Infrastructure has become a critical part of AI performance. And this is why technologies such as GPU, high speed Ethernet, InfiniBand, RDMA, NVLink, Kubernetes, and distributed storage systems are becoming essential knowledge for the modern infrastructure teams. AI workload demands extremely low latency, massive parallelism, and high throughput communication between systems. Traditional infrastructure designs built for the web application are often unable to efficiently support these new requirements. As a result, companies are redesigning data center specifically for the AI. The industry is already shifting rapidly. Cloud providers are building dedicated AI regions. Enterprises are deploying GPU clusters internally. Telecommunication companies are integrating AI into network operations. Cybersecurity platforms increasingly rely on AI-driven detection systems. Even storage and network vendors now design products specifically optimized for AI traffic patterns. And the GPU communication infrastructure engineers who understand these changes will play a major role in the next generation of computing system. Understanding AI does not mean every infrastructure engineer must become a machine learning researcher. Instead, it means understanding how AI workload behaves, how models consume compute resources, how distributed training operates across network, and how modern infrastructure is evolving to support these system requirements. Just as virtualization and the cloud computing reshaped infrastructure engineer over the last 2 decades, AI is not driving the next major transformation. The future of infrastructure is increasingly AI-centric. Data centers are evolving into the large-scale AI factories powered by GPUs. high-speed networks, and the intelligent orchestration system. Engineers who understand both infrastructure and AI will be the uniquely positioned to design, optimize, troubleshoot, and scale the system powering the next era of computing. Thank you for watching, and I will see you in the next section.